Hi everyone, and welcome to this first lesson of circle geometry. Today we're looking at theorem 1, which says that the line from the center of a circle that is perpendicular to a chord bisects the chord. Now what does all of this mean? Well, when we start at the center of a circle and we draw a line down and we draw it perpendicular on a chord, it means that this chord will be bisected, which basically means that AC will have the same length as BC. Now let's show the proof. Now the first step is we're going to write down what was given to us. Now we are given circle O with OC that is perpendicular to chord AB, and then we write down what we want to prove. So we write down to prove that AC is equal to BC. So we want to show that AC is the same length as BC, because then we just proved that when a line is drawn perpendicular on a chord, it bisects that chord, right? And then we're going to do a construction. So I write down construction, and then I'm going to draw OA and OB. So there is OA, and then I draw in OB. There it is. And now I can start my proof. So I write down my proof, and then I'm going to look in triangle AOC, which is this red one, and I'm going to look in triangle BOC, which is this blue one. So I write down in triangle AOC and triangle BOC. Now why do I want to look into these two triangles? Well, I want to try and show that these two triangles are congruent. Okay, so here we go. So to show congruency, we need to find three things that is true in this triangle that is also true in this blue triangle. So here is the first one. I can see that AO is the same length as BO. So I write down AO is equal to BO. Can you tell me why? Yeah, because both are radii. So don't forget your reason. Then the second reason for congruency is that OC in the red triangle is the same length as OC in the blue triangle, because they are both in common. Okay, so I can write down OC is equal to OC. My reason is that it is in common. And then my third reason is that C1 is the same size as C2, because both of these angles are 90 degrees. So I can write down angle C1 is equal to angle C2. They're equal to 90 degrees. And I include this 90 degrees because I know their sizes. Okay, so how do I know all of this? Because it was given to us. And now I've got the three reasons to show that these two triangles are congruent. So I write down triangle AOC is congruent to triangle BOC, and then I have to write down one of the four reasons for congruency. Now AO is the hypotenuse in this right angle triangle, and BO is the hypotenuse in this right angle triangle, and they are the same. So these two sides are the hypotenuses for both the triangles. Then we have OC and OC, which is just this side of this red triangle is the same as this side as the blue one. So it's just a normal side in the right angle triangle. And then we've got the 90-degree angle, right? So our reason will be a 90-degree angle. The hypotenuses are the same in both triangles. And then we've got a side that is the same for both the triangles. And there we go. So after we show that, we know that the red triangle is exactly the same as the blue triangle, which means that AC has to be the same length as BC. So I write down AC is equal to BC. And then what do we get from all of this after we're done? Well, there is a shorter way to write all of this once we get to the application, and you can memorize it so long. The shorter version for this theorem, when we are going to use it in application, is the line from the center is perpendicular to the chord. So memorize this so long. See you again soon. Bye.